Alright, math students, welcome back. This is lesson 6.1a, that's all about starting off with algebra. We're going to be talking about simplifying and factoring algebra expressions, and we're also going to use the distributive property a little bit. Alright, so let's talk about some terms first. Algebra sounds scary, but in reality, you've been doing algebra for a really long time. You just might not have thought of it that way. Okay? When we're talking about algebra here, we're going to be using letters or symbols. Let's just say letters. Could be other stuff too, but letters is mostly what we use. And those are going to represent some unknown variable. Let's call them mystery numbers. Something we don't know, and it could change. Now, what are these mystery numbers? They could be anything. It could be gas. It could be milk. It could be aircraft carriers. It could be pink unicorns. It could be pink unicorns with green sideways mohawks. Don't know. Don't really care to know. As long as we got a letter, we can work with it. Okay, when we talk about simplifying algebra problems, basically that means we're trying to shorten a math problem. We're trying to put all the stuff that's alike together so that we can make sense of it. So it's not some big, ugly, long, complicated thing like that. Alright, next. Factoring. When we factor, to factor is to take a number out of a math problem. We do that to make things as simple as possible so it doesn't look like that. We want it to look more short like that. Okay, an expression. Expression is a math problem without an equal sign. Okay, all these things below here, these are all expressions, right? There's no equal sign. It's like half of a problem. It doesn't tell you what it's equal to. It doesn't give you a final answer. It just gives you kind of the one side of the equation. All right, so let's work on simplifying an algebra expression first. All right, when we simplify, we're trying to put all the like stuff together. Okay, so here I've got this first one, 3b plus 7b. Now what does b equal? Don't know, don't care. Could be anything. All we need to know right now is it's b's. And there's 3b plus 7b. So when we simplify, we're just going to put all that stuff together, and that's going to equal 10b. Okay? Again, I don't have an answer. I don't know what b equals, but it doesn't matter. We can work with this. Let's do another one here. 14c minus 3c. Well, hey, they're all c's here, so we can add or subtract them, okay? 14 minus 3 is 11, so that becomes 11c. Here we got another one. Minus 4a plus 9b. Now you might want to just add those together. Minus 4 plus 9 is 5, but you can't because you got two different things going on here. It could be A is aircraft carriers and B is bananas. You can't add those things. They're totally different. Okay? I don't know what A and B is. All I know is there's something completely different and they don't mix. It's like oil and water. Okay? So when I try to simplify that, I can't. That's as far as it goes. I've got minus 4a plus 9b. I'm stuck with it for now. Let's try another one here. 12 plus negative 3c plus 7 plus 13c. Alright, so what we want to do here is we want to put all the stuff that's the same or alike together, like this 12 and 7. Okay, 12 plus 7 is 19. Alright, so I got all those together, and I've got a negative 3c and a 13c. When I put those two together, negative 3c plus 13c, that gives me 10c. So that's what that looks like. This long, ugly expression simplifies down to 19 plus 10c. All I did is I put the stuff that's the same together. Let's try another one here. 21d minus a negative 6 minus 5d plus 18. Okay, so I've got stuff with d's in here and I've got numbers. Alright, I can do a little same change here. This 21 stays positive. If I do same change, this becomes positive, this becomes positive. So now I've got a plus 6. And let me see here. I could do same change on this negative 5d as well. So that becomes plus negative. So plus a negative 5d plus 18. Okay, so I could rewrite this whole thing as 21d plus 6 plus negative 5d plus 18. Put all the stuff that's alike together. Take all your d's. Let's deal with those first. I've got a 21d and a negative 5d. I add those together and I get 16d. 6 and 18, add those together, are 24. Okay, so now I've taken this big, long, ugly expression and I've simplified it down to this. Okay, one more. 4x plus 9 minus 7x plus 5. Alright, so how about we deal with our numbers here first? I've got a 9 and a negative 5. I put those together and that's going to be a 4. Okay, I've got a 4x and negative 7. I put those together and that's going to be a negative 3x. So I've got negative 3x plus 4. I skipped the same change, just didn't work through it, but if you do same change, it'll work out just the same. Alright, so I go from big ugly expression down to something short. Alright, next up, before we get into factoring, let's talk about the distributive property. Distributive property can help us a lot when we're dealing with algebra, okay? If you guys remember back to our order of operations, the GEMDOS thing, or GEMDOS elements we used to do, you always did the stuff inside the parentheses first, right? Groupings come before multiplication, addition, and subtraction, right? So normally we try to deal with the stuff inside the parentheses, but unfortunately they're not alike. I've got x's and numbers, and I don't know what x's is. So I can't just add 3x plus 4 because it doesn't mean anything to me yet. It might be adding, I don't know, unicorns and numbers. You can't add those yet. So I just got to leave it. But I've got this 2 on the outside that multiplies against all of it. So what I can do is I can distribute that 2 across everything. Mr. Peterson talks about this as dropping the bomb. He's going to take a number 2 and he's just going to bomb everything. 2 times negative 3x and also 2 times 4. Okay? That's the distributive property. You're going to take that number on the outside of the parentheses and multiply it against everything on the inside, no matter what's inside there. Okay? So when we drop the bomb on here, I've got 2 times 3x is 6x. 2 times 4 is 8. Okay, so when you distribute that through, there's your new expression, 6x plus 8. Let's try another one here. Okay, now here I've got 4 times 3a, or in parentheses I've got 3a plus 5b. What are a and b? Don't know, don't care. Could be something completely different. What do unicorns and aircraft carriers have in common? Who cares? Doesn't matter. Let's do some algebra. Alright, so distribute this 4 across. We're going to drop the 4 bomb on the 3a, and we're going to drop it on the 5b. So first, 4 times 3a. 4 times 3 is 12, so that gives us 12a. 4 times 5 is 20, so that gives us 20b. Now I've got 12 of whatever a is, and 20 of whatever b is. And that's it. That's as far as you have to take it. Now let's do this one underneath. Looks super ugly, right? But it's actually pretty easy. It works just the same. We've just got more stuff to multiply now. Okay? We take our 5 bomb and we're going to distribute that against everything. We're going to bomb everything. Everybody gets a little dose of Mr. 5 here. Alright, so starting off, 5 times 6, 30. 5 times 4, 20. So 20x. 5 times negative 8, negative 40. 5 times negative 2x. That becomes negative 10x. 5 times 2 is 10, okay? So now we've distributed across, but now we have kind of a big, ugly expression. We can simplify it down. How do we simplify it? We take all the stuff that's alike, like this 30 and 40. Those are just numbers, right? Put those two together, we get a negative 10. 20x and negative 10x, put those two together, and we get a positive 10x. Okay, so now we've distributed the 5 across, and then we simplified. We put all the stuff that's alike together. One more. Alright, here I've got this other not quite so ugly expression, and it's got a 7 on the outside. So we're going to take this 7 and realize that that multiplies against everything inside our grouping here, okay? So we're going to drop a 7 bomb on everything. 7 multiplied by 2a, 7 multiplies against negative 8b, and 7 multiplies against negative 4. So the first one here, 7 times 2a, that's going to give us 14a. What is a? Don't know, don't care to know. 7 times negative 8. That's going to give us negative 56b. 7 times negative 4 is going to give us negative 28. Alright, now to simplify. Hey, I can't simplify. I've got a's, I've got b's, and I've got numbers. All that stuff is all different. It all means something else. So I can't put them together. Don't know what it means, but right now it doesn't matter. Alright, so that's the distributive property. It's basically multiplying across everything. Factoring is kind of like the opposite of that. Okay, it's using the distributive property backwards. So instead of multiplying across everything, it's basically finding something that I can divide across that whole fraction. Okay, when I use the distributive property, I went to having something in parentheses, some grouping, out to some really long expression. Well, now I'm starting with a long expression and I'm taking it back into grouping and multiplying. Okay, so it's working the exact same thing backwards. So how to do this? The trick is to figure out the biggest number that goes into everything. Okay, that biggest number that goes into everything is called the greatest common factor. And I'm just going to write that greatest common factor as GCF. Okay, that's the biggest number that goes into everything. So let's try it out here. I've got 12 and 18. The biggest number that goes into everything here is 6. Okay? And I'm just working through the first one here, the first example, to show you how to get these greatest common factors. Okay? I take my first number, 12. Okay? My factors of that are 1, 2, 3, 4, 6, and 12. I'm going to write that down. Go to my next number, 18 here. My factors of that, 1, 2, 3, 6, 18. What's the biggest number that goes into both of them? 6. Okay? You don't have to write this down. I'm just doing this as a quick example. Alright, so remember that 6 is greatest common factor. Now, all I need to do with that greatest common factor is I'm going to divide those numbers by that greatest common factor. I'm going to put that greatest common factor on the outside. I'm going to divide each of those numbers by it. Okay, so 12 divided by 6 is 2. So it becomes 2x down here. 18 divided by 6 is 3. Okay, so my new expression is inside the parentheses there, 2x plus 3. On the outside is 6. Okay, and you can prove it too, right? If I do the distributive property back on itself, 6 times 2 is 12x. 6 times 3 is 18. Okay, so I know it works. All I did, I found my greatest common factor, which is 6. I put it on the outside. I start dividing all this stuff by the greatest common factor, and that gives me everything inside my grouping there. All right, let's try another one here. 9 plus 6a. Okay, my greatest common factor. For 9, it's 1, 3, and 9. For 6, it's 1, 3, and 6. For 1, 2, 3, and 6. So my greatest common factor that goes into both of those is going to be 3. GCF equals 3. Okay? So I'm going to take that greatest common factor, 3. I'm going to put that on the outside. Okay? Now I'm going to divide everything else by 3. So 9 divided by 3 is 3. 6 divided by 3 is 2. Alright, so now my new expression, factored out, is 3 on the outside and a grouping of 3 plus 2a. Okay, I can prove it to myself again. I can distribute this across, and that's going to take me back to 9 plus 6a. Okay, so it works. Let's try another one here. Alright, 3a minus 6b plus 21. Okay, I've got a's and b's going on here. Don't know what they are, don't care. All I know is I can't add them or subtract them together yet because they don't mean anything yet. They're just different. So let's deal with it. Alright, find the greatest common factor between 3, 6, 21. Okay, I'm just going to go ahead and tell you it's going to be 3. 3 goes into 3, 3 goes into 6, 3 goes into 7, or into 21. Right? So GCF equals 3. Let's take our greatest common factor. We're going to put it on the outside of the parentheses. Okay, now we're going to divide everything else by 3. See what happens. 3 by 3 is 1, so that gives us 1a, or just a. 6 divided by 3 is 2, so it's going to be minus 2b. 21 divided by 3 is 7. So there you go. 3 in parentheses, 1a minus 2b plus 7. Okay, and again, I could do the distributive property again, times, drop the 3 bomb on all that stuff, and it's going to take me right back to that. Okay, so there we go. That's our factored out expression. Moving on. Okay, check out the try this problems. Work through these on your own. Pause the video, and when you think you've got them, hit play and check your answers. Okay, number 1. Simplify the expression. Here we've got some a's going on, and we've got some numbers. I can't just put them together. I have to put the like stuff together. Okay, so I'm going to separate out all the a's. So here I've got a 2a and a negative 7a. But if I add those two together, I'm going to get negative 5a. Okay, and I also have a negative 4 and a positive 9. Put those two together, and that's going to give us a positive 5. Okay, so I've got negative 5a plus 5. Alright, now if I really wanted to, I could factor those out as well. I could find the greatest common factor, take that on the outside, and that would become GCF equals 5. Okay, so I could take a 5 on the outside, right? Divide all this stuff by 5, and that's going to leave me with a negative a plus 1. Okay, 5 divided by 5 is 1. In this case, it's negative 5. 5 divided by 5 is 1. So I would accept either one of these answers, right? Negative 5a plus 5, or 5 parentheses, negative a plus 1. They both mean the exact same thing. Okay, number 2. Use the distributive property to expand the expression and simplify. Okay, so what do we do when we use the distributive property? We drop a bomb. We take the number on the outside and we multiply it across everything on the inside. So it's going to be 3 times 4, 3 times 2, 3 times negative 7. Okay, let's deal with the first one here first. 3 times 4 is going to be 12c. 3 times 2 plus 6. 3 times negative 7 is negative 21c. Okay? Okay, and that's that, right? These two mean the same thing. I could always factor that out, and it'd take me back to this. Greatest common factor would be 3. You know, if I divided everything by 3, it would take me right back to that thing again. So two expressions mean exactly the same thing. All right, number 3. Factor the algebra expression using the greatest common factor. Okay, so the first thing we need to do is figure out what the greatest common factor is of all these guys. And just looking at them, I'm going to tell you right off the bat, it's going to be 5. Okay, the only thing that goes into all this stuff would be, 1 and 5. So let's take a 5 out. I'm going to put my 5 on the outside. And if I divide everything else here by 5, sorry, give us a little more room here. So I take my greatest common factor, 5. I'm going to move it on the outside right here. Okay, now I'm going to divide everything else by 5. So 25b divided by 5 is going to give me 5b. 30 divided by 5 is going to give me 6. 15b divided by 5 is going to give me negative 3b. So there we go. That's as far as I can take it. I can't combine this stuff inside the parentheses because they're all different things. Okay, b's and... oh, wait a minute, hold on. I do have b's. I can combine that stuff inside the parentheses. All right, so let's do that. I thought I had b's and a's there. But I've got a 5b and I've got a negative 3b. So That's going to take us to 5b minus 3b is going to be 2b. Our 6 is going to stay the same, plus 6. And we'll bring our 5 on the outside. Alright, so that's as far as you can take it, as much as you can simplify it down. And that's a lot of what algebra really is. It's just, rearranging these expressions so they're more easy to use or more easy to understand. A lot of times you're not really changing the numbers, you're just shuffling around these expressions. I mean, all three of these things mean the same thing. Right here, this right here, and that right there all mean the exact same thing. As you get better in algebra, you'll get better at figuring that stuff out. Okay, thanks for watching. See you in class.